Stuck with ratio problems? This video is for you, where I share some challenging problems regarding the mathematical concept of ratio. So let's jump straight into the video. I'll focus on problem number 8 of the hard category of the mathematical topic ratio problem solving. So if I read the problem, it says Pieter owns a currency conversion shop. Last Monday, Pieter changed a total of 20,160 rand into a number of different currencies. So he changed 3/10 of 20,160 rand into euros. He changed the rest of the rand into dollars, rupees and francs in the ratios 9:5:2. So Pieter changed more rands into dollars than he changed into francs. So work out how many more. So the ratio is there, 9:5:2. Okay. So let's try this problem. So the total number is 20,160 rand. Okay, and he used 3/10 of this into euros. Changed. So he converted 3/10. If I use my pen tool, he converted 3/10 of 20,160 into euros. Okay, so if I cut this, what do I get? 2060 multiplied by 3. So this is what? 2 into 3, 6. So 6,016 into 3 is what? 16 3s are 48, I think. 10 3s are 36. 6,048. So this is the euro conversion. So this is the euro. So if this is the total number of euro, this is divided into the ratio of 9:5:2, among which three? Rest of the rands into dollars, rupees and francs. So this is dollar, the ratio number dollar 9, rupees is 5 and the franc is 2 in the ratio of this total number. Okay, so this the rest of the rands into dollars, rupees and francs in the ratio 9:5:2. So I have the ratio. This is the ratio of dollars, rupees and francs, and this is the total. So we know that obviously dollar is much greater than francs. So it says here that Pieter changed more rands into Pieter changed more rands into dollars than he changed into francs. Yeah, so he changed more dollars than he changed francs. So work out how many more. So how much more dollar did he change than francs? Okay, so let's figure out how much dollar did he change. So in terms of this ratio, if we add this 3 ratio, 9 plus 5 plus 2, we get what? 14 plus 2, 16. So 16 is the total, which represent this 6,048 euros. So the number of dollars, the amount of dollars is what? The amount of dollars is 16, which represents the total, and 9 is the amount of dollars multiplied by the actual number, which is 6,048. So if we divide 6,048 by 16, we get what? If I use my calculator, 6,048 divided by 16, we get 378. Okay, so 378 multiplied by 9 is what? If we use the calculator again, 378 multiplied by 9 is 3,402. So the amount of dollar is 3,402. This is the amount of dollars, the amount. Okay, and now let's figure what was the amount in terms of francs. So the franc conversion was what? The franc conversion was 2 in terms of ratio out of the whole, which is 16, multiplied by the total number, which is 6,048, which is this 6,048. So if we divide 6,048 by 16 and multiply by 2, we get what? I use my calculator. 6,048 divided by 16 multiplied by 2, we get 756. So 756 is the amount in francs. So how much more dollars did he convert than franc? So the amount of dollars he convert was 3,402, and the amount of franc conversion was 756. So the difference is what? the amount, the difference in terms of amount is 3402 minus 756. So if I use the calculator again, if I use the calculator, and 3402 minus 756 is 2646. So 2646 is the amount, that is the difference between dollar conversion and franc conversion that was required in the problem. So how many more dollars did he convert than franc? I'll now focus on problem number 11, which is slightly tricky. So let's read the problem. It says a bag contains some counters. There are 300 counters in the bag. So there are 300 counters in total in the bag. There are only red, white and blue counters in the black bag. So the probability of picking a blue counter is 23 by 50 or 23 is to 50. So the ratio of red counters to white counters is 2 is to 1. So calculate the number of red counters in the bag. So let's try this problem. So it says the total number of counters in the bag is what? 300. So this is the total. Okay. So now the second information is there's only red, white and blue counters. Okay. The third information is the probability of picking a blue counter is 23 by 50. So the probability of picking a blue counter is what? 23 by 50. That means if the total in terms of ratio is 50, then blue is a part as 23. So for example, this can also be written as 23 is to 50, right? So if the total is represented as 50, if the total is represented as 50, then blue is 23. So what is the rest? What is the total minus blue in terms of ratio? So the total in terms of ratio, total minus blue is what? 27, right? 27 is to 50. In terms of ratio, this is 27 is to 50. If blue holds 23 of 50, then the rest, the other part is 27. It's to 50, right? So keep that in mind, which is the rest is 27 is to 50. So the ratio of red counters, the fourth information here is the ratio of red counters to white counters is 2 is to 1. So the ratio of red counters is to white counters is what? 2 is to 1. So if the total is 3, which is 2 plus 1, then red is what? Red is 2 by 3 and white is what? 1 by 3. 1 by 3, right? So if the total is represented as 3 in terms of only red and white, excluding blue, we take blue aside, we take the only red and white, which is the other two, we have the ratio 2 is to 1, where red is this part and red is this part and white is this part. Okay, keep that in mind that only red, white and blue are in the bag. So we have calculated blue, we have been given blue, which is 23 by 50. So the rest is meaning red and white is 27 by 50. Okay, the rest, as this information, this contains what? Red and white, right? So now what we can do here is, if the red is 2 by 3, we can also represent this as what? If we multiply both numerator and denominator with 9, so we get what? We get 18 by 27, right? So what is the purpose of doing 27? The purpose of doing 27 is to match this with this ratio. Okay, this is the rest, which is red and white, that we are calculating. So you have to match the ratio numbers. That's why we are multiplying both numerator and denominator with 9. So we do the same with white as well. We'll multiply white with also both numerator and denominator with 9 as well. So we get what? 9 by 27. So now we can calculate. So we have red, which is 18 by 27. We have white, which is 9 by 27 in terms of ratio. Calculate the number of red counters in the bag. So the rest, keep in mind that the rest is 27 by 50. Okay, the rest is 27 by 50. Red is what? 18 by 27. 18 by 27, and white is 9 by 27. So out of this 27, red and white is distributed as what? 18 is to 9. So red is to white is what? Is 18 is to 9. Okay, so what is the amount of red counters? What is the amount of red counters? 18 by 27 into, we have to calculate this. What was the rest amount? So the rest was calculated as what? 27 by 50 in terms of ratio. But in terms of the number of bags, we can multiply this by 300 because this is the total number. This is the total. So what is the number of red and white bags combined? 27 multiplied by 6, which is what? We use a calculator. 27 into 6. This is 162. So 162 is the number of bags with red and white bags combined. So if I have 162 as red and white bags combined, the number of red is what? 18 by 27 multiplied by 162. So if we use the calculator again, and 162 divided by into 18 divided by 27, we get 108. So this is what? 108. So the amount of red counters is 108. So what we did here as a summary is, first we have the total, then we calculated the rest because blue is given, the rest meaning red and white proportion is given. So we can get the number which is this, which is red and white combined. Then we calculate the ratio which is of course given, red is to white, and we match it by multiplying denominator and numerator with 9 to match 27. Okay, so when we match 27, we get red is 18 by 27 and white is 9 by 27. So when we get red as 18 by 27, we multiplied it with the rest that we calculated here, rest meaning red and white combined. So then we get the amount of red counters. So this is how we solve the problem. I'll focus on problem number 14. Problem number 11, 12, 13, these are very similar, and I've done previously this type of problems. So I'll focus on problem number 14, which is slightly tricky and very interesting problem. So let's read the problem. It says, in a village, the ratio of males to females is 2:1. So in a village, the total population is distributed male to female 2:1. Okay. So this is the first information. The second information is the 40% of the entire people or the entire population of the village are right-handed males. Right-handed males. 25% of the entire population in the village are right-handed females. So you have to show that the proportion of females who are right-handed is greater than the proportion of males who are right-handed. That means the proportion of females, or the percentage, you can say the percentage of females who are right-handed of the female population is greater than the percentage of males who are right-handed of the male population. Okay, so let's demonstrate this. Let's use the notepad, and I'll use my pen tool. So what is the information given? The very first information given is the ratio of males to females. Okay, so the ratio of male to female in a village is 2 to 1 or 2 is to 1. Okay, so the male part is basically 2/3, and if I add 2 and 1 we get 3. So the male part is 2/3 and the female population is 1/3 of the entire population. Okay, so 40% of the village of the people of the entire population, 40% of it are right-handed males. So if I denote right-handed males as MR, right-handed males, so 40% of the entire population. So if I turn it into ratio, it would be like what? 40, first I divide by 100. So we get what? 40 divided by 100 is what? 4 by 10. So it can also be shortened as 2 by 5. So we can write 2/5 of, or we can also write it as 2:5, or 2/5 of the entire population are right-handed males. So 5% of the people in the village are right-handed females. So if I denote right-handed females as FR, so 25% of the entire population are right-handed females. So this is what? 25. If I turn it into a ratio, it would be what? 25 by 100, or this can be represented as 1/4. Okay, 1 by 4, or we can represent it as 1:4, or 1/4 of the entire population is right-handed females. If the entire population is 4, the female is 1. Right-handed females is 1. If the entire population is 5, right-handed males are 2. Okay, so this is the information given. So you have to show that the proportion of females who are right-handed is greater than the proportion of males who are right-handed. So if I want to, I have to show that the proportion of females. So the proportion of females who are right-handed, this is FR. If I denote females as F, so I have to show that the proportion of females who are right-handed is greater than the proportion of males, who are right-handed. So how can we do that? So as you can see, this is probably the most important information, which is the entire population is distributed male to female as 2 to 1. So if I I can write this as what? Twice n is to 1n, where n, this can be any integer representation. Okay, so I turned the ratio into actual number, or the number of people. So what is the total population then? If I represent the total population as t, I get what? Twice n plus n, or 1n. 1n is basically n, or this is thrice n. So the total population can be denoted as thrice n. So if the total population is thrice n, what is the ratio of right-handed females by females? So what is the, if the total population is thrice n, what is male part? The male part is what? Twice n, and the female part is n, because they are distributed 2:1. Twice n is to 1n. So male is twice n and female is n. So this is the entire male population, and this is the entire female population, and this is the total population, male plus female. Okay, which is thrice n. Male is twice n, female is n. So is the amount, or the number of right-handed female population. So we already know that the right-handed female population is 1/4 of the total population. So this is basically 1/4 of the total population that we denoted as T. So this is what? This can be represented as 1/4 into the total population, we denoted it as thrice n. So the total population is thrice n. So 1/4 of thrice n is what? We can represent it as thrice n by 4. So this is the right-handed female population in number. In number, this is thrice n by 4, not in ratio. So we can also now figure out what is the number of right-handed males. So the number of right-handed males is what? We know that the right-handed males are 2/5 of what? This can be represented as 2/5 of the entire population, or T. Okay, so T is what? Thrice n. So this is basically 2/5 of the entire population, or the entire population is thrice n. So this is what? 6n by 5, right? So the male population, right-handed male population is 6n by 5. The right-handed female population is thrice n by 4. So now we can figure out this ratio, which is the percentage of, or the ratio of right-handed females by the total female population. So this is what? The right-handed female, we know that this is thrice n by 4. So we can write thrice n by 4. And what is the total female population? The total female population is n, right? So if I cut off n, I get what? I get the ratio. This is the ratio. So what is the ratio? 3 by 4. So 3 by 4. Okay. So if I turn it into percentage, I just multiplied it by 100. So I get what? 75%. So 75%. So this is basically 4 divided by 100 divided by 4 is 25. So 25 multiplied by 3 is 75. So 75% is the percentage of female, right-handed females by total number of females. So similarly, we can figure out what is the percentage or the ratio of right-handed males by the total male population. So what is the right-handed male population? We figure it out, 6n by 5. Okay, so 6n by 5. And what is the male population, the entire male population? Twice n. So if I cut off n and divide 6 by 2, I get 3, and this is 5, of course. So we get what? 3 by 5. So if I multiply it by 100, I get what? The percentage. The percentage is what? 20 multiplied by 3, which is 60%. Okay. So as you can clearly see, 75% is greater than 60%. So the percentage of female, right-handed females by, or the right-handed female females of the female population is 75%, and the right-handed males by the male population is 60%. So FR, or the right-handed females compared to the female population, is greater than the right-handed males by the male population. So this was what was required. The proportion of females who are right-handed, the proportion of females who are right-handed, this is 75%, and the proportion is greater than the proportion of males who are right-handed. So the proportion of males who are right-handed is 60%. So 75% is greater than 60%. So this was what was required in the video. By now you should have a firm grasp on the mathematical topic of ratio. So in the next video I'll focus on another mathematical topic. So stay tuned for that, and meanwhile you can watch this video that I highly recommend. Until next time, see ya.